Hi, it's Mr. Kingsbury. I have one final thing I want to share with y'all regarding exponentials. We're kind of done with our look at logarithms, but there's one final thing that exponential functions have that's really useful and important in today's society, and that would be compound interest. Now, these formulas are what banks and other institutions that invest money use every single day to figure out how much money their clients are earning or losing or what have you. We're only going to look at stuff where we're gaining interest. So we'll look at things, investments, not the stock market so much, but investments like a savings account or a bond or things like that where you only gain money the entire time. So what I have here is the compound interest formula, and then down here the continuously compounded interest formula. And let's see if I can break it down really quick. So you may remember that the growth formula is exponential growth formula. Y equals A times 1 plus R raised to the X power. You'll note that this looks very similar. We've got an A and the Y, the 1 plus, only now instead of R, it's divided by N. And instead of X, we have T. X and T are the same thing. They're the amount of time. It's actually usually the amount of years, but there's also an N up here. Okay, so here's what's going on. You stick money into an account, and you have some annual percentage rate. All right, that means that by the end of the year, your money will have grown by that percent. Real simple example would be if you stick $1,000 in an account that has a 5% interest rate. 5% of 1,000 is $50. So by the end of the year, your account will have raised $50. That's the idea. Now, what happens is that institutions don't want to just stick that money in there at the end of the year. They want to stick it in there more frequently so that you see that your money is working for you. So they will put that money in your account frequently throughout the year. And it depends. It could be once a month, once a day, once a week, could be twice a year, who knows? But that's when they're what's called compounding it. Anytime they put that interest in there, they compound it. And what's really great is what works for you is instead of it ending up adding up to how much you're supposed to make by the end of the year, you actually start earning interest off of the interest. So you end up not earning just that $50, but more so because you're getting interest off of the interest. I said it before, but it's worth noting again. It's very cool. So when we talk about compounding, that's how many times per year money is stuck into your account. And these are all money related. Every last one of them will deal with money, guaranteed. All right. So that being the case, we need to know what words to look for so we know how often something is compounded. So that's why we have these N words right here. So annually means once a year. Biannually means twice a year. Monthly is 12 times a year because there's 12 months in a year. Weekly is 52 because there's 52 weeks in a year. Daily, we are going to go for 365. There's 365 days in a normal year. Don't ever assume a leap year. Financial institutions don't want to give you that extra day because that's more money out of their pocket. There are 8,760 hours in a year, and this is my favorite, 525,600 minutes in a year. So be on the lookout for those words. They will tell you what number to use for N. Now, we're just going to write these. We're not going to calculate them. Okay? You may have noticed, by the way, that these words got steadily larger, right? We went from once a year to 600,000 times per year. And we could go on to seconds and milliseconds. And at some point, it becomes so frequent, they compound the interest so frequent that it never stops. When that happens, we call that continuously compounded interest. And that's where that number E comes in. And I don't know why they choose to use P here instead of A. It's the same thing. It really is the same thing. P and A are that initial amount. that you invest. Okay. By the way, these variables have not changed other than n is a new variable. E is that constant. So now instead of 1 plus some rate, you just have a constant of E. And notice the rate is moved up here. And there is no n anymore. That's how they've adjusted it. Now, we can talk about where this comes from if you would like, but I would like to focus more on how do we write these equations. And that's all we're going to do. So look for the keywords either continuously compounded or compounded continuously to know that you're using continuously compounded interest formula. If it says compounded any of these words, you use just the straight normal compound interest formula. So let me just show you a couple of these so that you can see how it's done. Number one, if you deposit $2,000 into a savings account that pays 4.3% interest and compounds interest weekly, then how much will you have in 6 years? The weekly tells me we're just using a regular compound interest formula. So I need to know what A, R, N, whoops, that should be N, then T, and then Y. Y is not included up here. It's not included in here, but it is part of the formula. So let's start at the top and work to the bottom. A is the initial amount. That's $2,000. R is the rate. That's 4.3%, which, if I move the decimal 2 places to the left, is 0.043. N, it says weekly. Weekly is 52. T time is T time is 6 years. And then Y we don't know. The equation, which I'm just copying from right here, just copying this guy. The equation is Y equals A times 1 plus R over N raised to the NT power. Let's plug in. We don't know what Y is. We know that A is 2,000. We got 1 plus. R is 0.043, and that's over N. N is 52. Close the parentheses. Then we have the exponent, NT. N is 52 again, and T is 6. And I put the parentheses in there because if I didn't, it would look like 526. So I either need to put like a dot or the multiplication sign or parentheses. I steer clear of using the multiplication sign because it looks like an X. And I don't want people to get confused. So there's that. And by the way, that's the equation I'm looking for. Let's jump down here to number 3. You've deposited $4,000 into an account 3 years ago. The account compounds your interest daily. If you have $5,000 in the account today, that's 3 years later, at what interest rate did they compound your money? Interesting. So we will use because it's compounded daily, we're going to use the regular compound interest formula. So we need to know what A, R, N, T, and Y all are. So the initial amount is $4,000. And look, it says that was 3 years ago. So T is going to be 3 years. Now we have $5,000. That's our final amount. That's our Y. And it says it compounds daily. There are 365 days in a year. So I put 365. What interest rate did they compound your money at? We don't know. This is the thing we're not going to be sure about. So let's plug in. Our equation is Y equals A times 1 plus R over N raised to the NT power. My Y is 5,000. My A is 4,000. 1 plus R, because we don't know the rate, but we know that N is 365. Close those parentheses, and then the exponent will be N, which is 365, times T, which is 3. And that is my equation. Cool. Let's try another one here. Number 4. If you deposit $3,000 into an account that pays 6.1% interest compounded continuously, how much money will you have after 8 years? Excellent question. So we're using the compounded continuously equation, which looks like this. I call it the PERT, P-E-R-T equation. That's just me. Hopefully you remember the variable, PERT. So P, I don't need to write E because E is a constant. But I need to write R and T and remember that it equals the Y. So what are all these things? My P is my initial amount, that's 3,000. It pays 6.1% interest. So my rate is 6.1%, and I need to convert that to a decimal. So I move the decimal point 2 places to the left. I get 0.061. T is 8 years. Why? I don't know, because it says how much will you have after 8 years. So, who knows? Now the equation is Y equals P times E to the RT. We don't know what Y is. We know that P is 3,000. E is a constant. It's not a variable. It's like pi. It's a symbol that represents a number. So I'm just going to put E in here. My R is 0.061. And then my time is 8. So I'll put parentheses and an 8. Otherwise, it'll look like 0.0618. I don't want that. I want 0.061 times 8. And it looks like I put too many parentheses in here. So let's fix that. Sorry about that, but that's my equation. Amazing. One more and then I'm out of your hair. Number 5, if you have $7,000 today to deposit into account and you need $12,000 after college in 7 years to buy a house, what interest rate would you need in an account that compounds continuously? All right, so we're dealing with a continuously compounded situation. That means we will use the PERT equation. P equals E times R to the T. Don't forget Y. Let's fill in. I have $7,000 today. That's my initial investment. And I need $12,000 when I'm done. That's my Y. $12,000. We need that in 7 years. That's going to be my T, will be 7 years. And then it asks, what interest rate would you need? So we don't know what R is. So we got Y equals P times E to the RT. Let's plug in. Y is 12,000. Whoops. I don't know why I did that. Ignore that. P is 7,000. Times E, I don't change that, to the R. We don't know what R is, but we know that T is 7. And remember that mathematicians tend to like to put the number first when you're multiplying a number in a variable. That's why I put the 7 first. Technically, though, if you wanted to put R7, that's fine. I just switched them because that's the convention. There's my equation, guys. Pretty amazing. Thanks for your attention. Appreciate it, and I'll see you in class.